Homework M1, question 6. We've got a vase with a circular cross-section. We've got its equation, V equals 4 pi h times h plus 4, where h is between 0 and 25. And we're told that water flows into the vase at a constant rate of 80 pi centimeters cubed per second. We've been asked to find the rate of change of the depth of the water in centimeters per second when h is equal to 6. So this is a related rates of change problem. Taking that third line of the question, water flows into the vase at a constant rate of 80 pi. That 80 pi is the value of dV dt. You can always find that by looking at the units are involved. Centimeters cubed is measurement of volume, per second gives you the over t element to it. The thing that we've been asked to find is the rate of change of the depth of the water, so we've been asked to find dH dt. Now, using the chain rule, I can find dH dt if I had dH dV times by dV dt. Essentially, these two v parts here will cancel and leave me with a dH dt. You can't actually cancel parts of a differential, but in essence, that is what we're doing. dH dV is going to be a little bit awkward to find. However, I could rewrite that as, instead of timesing by dH dt, dividing by dV dH, and that is going to be much easier to find. So, to be able to find dV dH, I want to expand that bracket. I could use the product rule, but in this case it is so much easier to write that as 4 pi h squared plus 16 pi h. And then I can differentiate as normal. dV dH then is equal to 8 pi h plus 16 pi. Plugging that and my value for dV dt in, I get dH dt is equal to 80 pi over 8 pi h plus 16 pi. We know the value of h that we're working with. At h equals 6, dH dt is equal to 80 pi over 48 pi plus 16 pi. So that's 80 pi all over 64 pi. I can cancel the pi from top and bottom, and if I simplify 80 over 64, that gives me 5 over 4. And my units are centimeters per second.